Alright, for the second part of the video, let's talk about problem 2. So problem 2, we also have a joint density function equals b, and the definition region is x squared plus y squared smaller than 1. The first question, we need to find a b to make this joint density function valid. So because we have this definition region, we can transfer this random variable to the polar coordinates like this: x equals r times cosine theta and y equals r times sine theta. Alright, and the definition region in the polar coordinates should be r squared smaller than 1. Okay, let's do the integral thing. For theta, it's 0 to 2 pi, and for r, it's 0 to 1. So it's b times r dr d theta equals 1, and it's easy to get that the result is b times pi equals 1, and b equals 1 over pi. Alright, the question 2. So question 2, we need to find a bunch of expectations. Yeah, there are conditional expectation and the original expectation. So first, let's try to find the expectation of x. So in polar coordinates, we know that the expectation of x is the expectation of r times cosine theta. So the equation is like this: r times cosine theta times b, which is 1 over pi r dr d theta, and the result is 0. Okay. And then we can draw a figure like this. So this is x and y, and we know that for a conditional expectation e x given y, no matter how large or how small this y is, for example y is this point, the x or the expectation of x should be 0. Okay. So the expectation of x given y equals small y is also 0, and then the expectation of y is the integral of from 0 to 2 pi, from 0 to 1, r times sine theta times r dr d theta, and also the expectation of y is 0. And in this figure, we can see that well, it's actually the same as how we get the expectation of x given y. Because no matter, for example, when x equals this, we can draw a line here, and the expectation of y given x equals, for example, this is a, for given x equals a, y given x equals a is 0, right? So the conditional expectation of y is also 0. Alright. So the last question, question C, we need to prove or disprove x and y are uncorrelated. Also, we need to find the expectation of x and y. It should be, let's take the 1 over pi out of the integral, and it's 0 to 2 pi, 0 to 1, and r squared times sine theta cosine theta here. There's a R there, this theta. Okay. So actually it's 1 over pi. And it's an easy calculation. We know that the expectation of x times y is 0. So the expectation of x times y equals the expectation of x times the expectation of y. Because these two we have had the result in question B. They're all 0, 0, and 0. So they are uncorrelated.